Exponential growth and decay. Exponential growth is something that increases like compound interest, superannuation, goes up. Exponential decay is like half-life, and it goes down exponentially. Exponential growth, exponential decay. It'll actually go like that. Anyway. Alright, when a substance grows or decays exponentially, its rate of change is directly proportional to the amount of the substance itself. That is, the more the substance, the faster it grows. And that's where we get the exponential from. In maths, exponential growth and decay can be written as, so if I've got something growing or decaying, so if it's growing over time, it's some constant times its original amount. If it's decaying, it would be a negative constant. If it's growing, it's a positive constant. Because it's an exponential function, we say that the original function is what we started with, growing at some rate, some exponential power. How do I get this as my initial? Well, when t is 0, all that will equal 1, and it will just be a. This formula does not change. These are my exponential growth and decay formulas. dq dt equals kq, where q is this. Now, if I find dq dt, I bring the power out the front, and I differentiate. Isn't that k times the original? And what would happen if it was decay? It would be a minus k out the front there. Okay, let's have a look at some questions. Waste from a chemical factory falls in a pipe so that R, the rate of increase of the volume, is given by K R, which is dV dt, is given by K pi T squared, where K is 0.75 and the area under the pipe is cleared before the factory begins operation every day. What is the volume of waste after 2 hours? This hasn't actually even used this part, so I don't know why. It's from the previous question. If I want to find volume, I need to integrate. So I'll just finish it and then we'll come back to this. So if I want to find volume, I integrate. So it's 0.75 pi t cubed on 3. And that's when it's 2 hours. So let t equal 2. Sorry, bad example. Let's go on. Water flows from the tank such that the number of litres remain in the tank after 10 is given by, this is more like it. So you can see that this is in the form of Q equals A, e to the minus kt. And they've given you K. It says find the rate at which water flows after 30 seconds. Find the rate. dL dt is minus K, because I'm differentiate, 5,000 e to the minus kt. I know what t is, I know what k is, and I know I can sub it all into my calculator. I'm going to have to get another example where we have to find the unknown. It's quite easy just to sub these numbers into our calculator, but when I have to find the unknown, it gets a bit, the power is an unknown, I have to use a logarithm. So I'll do an example of that in another video.